For part 2 of lesson 5.9, we're actually going to get into an application problem, something called vertical motion models. Every time an object is thrown or launched upwards, the bottom line is that projectile will follow this formula that we have at the top of the screen. And if you're in physics, perhaps you've already learned that. Perhaps that's been told to you. But you're going to see that the height, h, of this object, that's what h is, it's equal to negative 16t squared, where we're measuring our height in feet, by the way. That's very important. So it's negative 16t squared plus, this is read v naught, this v with a little zero there, v naught times t. V naught is actually the initial velocity. You're going to be given that information that an object is thrown with a beginning, that's what the word initial really means, a beginning velocity. Finally, h naught, and whenever we see naught, it means beginning, is the initial or the beginning height. So what's going to happen is you will be told some pieces of information, and you're going to be able to write out an equation that will describe the height of the object for any given time. Let's read example 3. A baton twirler tosses a baton into the air. The baton leaves her hand when it is 6 feet above the ground. Now that is a beginning height. When you think about feet, you usually think about that in terms of height. So the beginning height is 6. The initial or the beginning vertical velocity is 30 feet per second. So v naught is going to be 30. And all they want you to do for part A is to write an equation that gives the height as a function of time. So for part A, we're going to be following this equation right here. H is equal to negative 16t squared. What's our beginning velocity? Well, in this problem, it's 30. So v naught, the beginning or initial velocity, is 30. Notice also when I'm writing my t, I'm putting a little hook at the bottom so I don't mistake it for a plus sign. That's very easy to do. Finally, we're going to say plus the initial height. Well, the initial height is 6. Believe it or not, we are now done with part A. I've just found my initial velocity, my initial height. I've written them into that formula. This formula can tell me the height for any given time. So you could say plug in t equals 2. 2 seconds after this girl has thrown the baton up in the air. If you let t equal 2 and work that out, you'll know how high the baton is from the ground, what the distance from the ground is. Well, for part B, if the baton twirler lets the baton hit the ground, in other words, she doesn't catch it in her hand, she just lets it hit the ground, find the time when the baton lands on the ground. Well, when you're landing on the ground, for part B, to land on the ground means that the height, the distance that the baton is from the ground would be 0. In other words, we have this 0 is equal to negative 16t squared plus 30t plus 6. And why is that so important? This is now solving this equation. If you can find out what t is to make this true, you'll know when the baton hits the ground. Now, earlier on that first video, we learned how to solve a quadratic equation every single time, whether we'd be able to factor it, whether we'd be able to take square roots. The quadratic formula will always come to our rescue. And the quadratic formula is opposite b plus or minus the square root of b squared minus 4ac all over 2 times a. So what's going to happen here is we'd like to identify our A, our B, and our C. And I'll tell you what, the A, I hope it's pretty obvious to you. It's this number in front of the squared term. It's negative 16. The B, well, that's the number in front of the linear term or the x term or the t term. That's going to be 30. C, the constant, hey, that's your initial height. That's 6. And I'll tell you what, just like we did on that front page of the notes, just like we did in part A or part 1 of the video, let's store all of these values in. I'll type negative 16, hit the store button, then type alpha A. Type 30, hit the store button, then hit alpha B. Finally, we'll hit 6, hit the store button, and then hit alpha C. Here's the thing. On the front page, we just used this information to get the interior, that inside of the quadratic formula. The reason was, more often than not, we're going to have radical answers, and we want to break down the radical. We don't want to just have a decimal. Here, we do want to have a decimal. We'd like to know what time, even if it's something like 3.9 seconds or something like that. We'd like to be able to not answer in terms of a radical, but in terms of a decimal. So, here's what we can do. We can just type the quadratic formula out. First, let's get a fraction. Alpha y equals, and hit the n over d. And I'm going to type opposite alpha b. We have to do one of these at a time, so I'll just do the plus. I'll say square root of alpha b squared minus 4 alpha a alpha c. Bring this down here and just type in 2 and then alpha a. In other words, we're letting the calculator work out the quadratic formula for us. Very peculiar. You might look at this and think, oh my gosh, this is so weird. I'm getting a negative 0.18. And you might think about that for a second. Is that going to make any sense that negative 0.18 seconds after she threw the baton, it hits the ground? No, we're not going to have negative time. The bottom line is there's a second answer coming. Let's see, perhaps, if we could fix that up. Let's hit second enter. Second enter will allow us to retype what we have, or get to what we've just typed real quickly without having to retype it. I'm going to put the cursor over the plus and just change it to a minus. And maybe, just maybe, this will help us out. When we hit enter, you can see we'll get about 2.1. So that's actually the answer that's going to make sense. We'd say t equals about 2.1. And we can say then that the baton hits the ground 2.1 seconds later. So please be on your guard. There are two answers that you're going to get for these problems. Very often the first one, the one with the plus, you're going to see that you might not be too happy to see that. You might get a negative answer. That would be ridiculous. You'll have to throw out your negative time. But very well, you could just go with the opposite B minus. And hopefully that will really help you out.